Polyatomic ions like carbonate, sulfate, nitrate, nitrite, and ammonium are essential building blocks of a wide range of ionic compounds. They drive fascinating chemical interactions critical to chemistry and everyday life. They generally pair with metals to form ionic compounds. They also pair with other polyatomic ions to make compounds, with one serving as a cation and the other as an anion, maintaining overall charge neutrality. Hi everyone, this is Akhilanand Singh. Today we will explore the names, charges and formulas of the most common polyatomic ions and uncover how they unite with other ions through ionic bonding. Let's get started. What are polyatomic ions? Polyatomic ions are pre-existing ions composed of two or more atoms covalently bonded together, carrying a net charge due to the gain or loss of electrons. Once formed, the polyatomic ions act as single units and combine with other ions to form ionic compounds. For example, the sulfate ion consists of 1 sulfur and 4 oxygen atoms with collective charge of -2. It creates an ionic bond with calcium and forms calcium sulfate. Pairing with sodium, it creates sodium sulfate. Similarly, the ammonium ion is composed of 1 nitrogen and 4 hydrogen atoms. It combines with a nitrate ion to create a stable compound, ammonium nitrate. Let us have a look at a list of common polyatomic ions. The list categorizes ions based on their net positive or negative charges. Some common anions with -1 charge are bromate, chlorate, chloride, nitrate, nitrite, hydroxide, acetate and bicarbonate. Ammonium and hydronium ions have +1 charge. Carbonate, sulfate, sulfite and peroxide are some of the ions with -2 charge. Phosphate, phosphite and arsenate anions are the ions with -3 charge. These are versatile ions instrumental in forming a number of compounds. We should try to remember their names, formula and charges. There is a pattern in their names, especially those having oxygen atoms. Such ions are anions and they are called oxyanions. Understanding their naming pattern helps us remember them easily. Naming patterns for polyatomic oxyanions. Oxyanions name is derived from the name of the base ion, which are typically nitrogen, chlorine, bromine, etc. Their suffixes are based on the count of oxygen atoms in them. The suffix "ate" is used for the oxyanion with the most oxygen atoms in a series. For example, sulfate has 4 oxygen atoms. The suffix "ite" is used for an oxyanion with one fewer oxygen atom than the ate ion. For example, sulfite ion has 3 oxygen atoms, one less than the sulfate ion. The prefix "per" is added to the ate ion with one more oxygen than the standard ate ion. For example, perchlorate ion has 4 oxygen atoms, one more oxygen than those in chlorate ion. The prefix "hypo" is added to the ite ion for an oxyanion with one fewer oxygen than the ite ion. For example, hypochlorite has one less oxygen than the chlorite ion. Ionic compound formed with polyatomic ions also follow cation-anion naming pattern, where metal is a cation and the polyatomic ion is an anion. When they combine with another polyatomic ion to form a compound, one of them plays the role of a cation and the other becomes an anion. While naming such compounds also, we follow the cation-anion naming pattern. Please note that we do not use prefixes like di, tri, tetra, etc. In the first example, we consider an ionic compound formed by a metal and a polyatomic ion. Here the polyatomic ion is a carbonate anion, which is covalently bonded by carbon and oxygen atoms. It has an overall charge of -2. A calcium cation is a metal having 2 positive charge. When they interact, an ionic compound is formed. One ion each of the cation and the anion is enough to neutralize the total charge of the formed compound. The formula of the compound is CaCO3 and it is named calcium carbonate following the cation first anion later convention. In this example too, we discuss an ionic compound created by a metal and a polyatomic ion. This time the polyatomic ion is a sulfate anion with an overall charge of -2. The sulfate ion is made of 1 sulfur and 4 oxygen atoms who are bonded together by covalent bonds. When the sulfate anion meets a calcium cation having 2 positive charge, their charges balance each other and they create a stable ionic compound. The formula of the resulting compound is CaSO4. It is named calcium sulfate following the cation plus anion naming pattern. Our third example has a carbonate anion with -2 charge. Let us see how it pairs with a sodium cation which has a +1 charge. When two sodium cations combine with a single carbonate anion, their overall charge becomes 0, creating a stable ionic compound. Following the cation first pattern, the formula of the resulting compound is Na2CO3 and its name is sodium carbonate. In the fourth example, we have a sulfate anion with -2 charge combining with a sodium cation with a +1 charge. To create a stable compound with a neutral charge, two sodium cations combine with a single sulfate anion. The compound thus formed is Na2SO4 and it is called sodium sulfate. Example 5. In this example, we witness a union of two polyatomic hydroxide anions with a metal calcium cation. We can examine the periodic table of ionic charges and see that the cation Ca has +2 charge. From the chart of common polyatomic ions, we can get the charge of a hydroxide anion as -1. To create a stable compound with a neutral overall charge, two hydroxide anions will be required to bond with a single calcium cation. Their union results in a compound with the formula CaOH2 and the chemical name calcium hydroxide. Our sixth example discusses a compound formed by two polyatomic ions, in which one polyatomic ion is a cation and the second is an anion. Ammonium ion is the cation which has a +1 charge and nitrate ion is the anion with a -1 charge. Combining one ion each, they create a stable compound with a 0 overall charge. The compound so formed has the formula NH4NO3 and it is named ammonium nitrate. Example 7. Let's see another compound formed by the union of two polyatomic ions. Here the first polyatomic ion is a ammonium cation with a +1 charge. Sulfate anion is the other polyatomic ion with a -2 charge. For a neutral overall charge, two ammonium cations are needed to unite with a single sulfate anion. Thus the compound formed is ammonium sulfate with the chemical formula NH42SO4. In the final example of this video, we have a pairing of a transition metal with a polyatomic ion. The transition metal is copper, which has a dual charge states +1 and +2. In the +2 state, it ionically bonds with a sulfate polyatomic anion with a -2 charge. Their one-on-one pairing forms a neutral ionic compound CuSO4. The compound is named keeping two naming conventions in mind: the standard ionic naming convention and the stock naming convention, since it has a transition metal in it. Thus, it is named copper 2 sulfate. 2 in Roman numerals is used to indicate the charge of the cation copper. That's all for this video. So far in this series, we have been discussing covalent and ionic compounds. In the next video, we will compare the strength of different types of chemical bonds. If you haven't watched the previous videos of this series yet, make sure to check them out for a deeper understanding. Thank you.